This is gonna be interesting. Filter in, filter out, filter in, filter out, filter in, filter out, filter in, filter out, filter in. Still in. Still in. Now, I hope you guys enjoy this episode, because this will be a heck of a one itself. Firstly, today we're going to talk about light and sound, which is why we're going to need these bad boys if they work. It's been a while. Well, I hope they work, because I really want to see rainbows. Now, waves, light, sound. They're the most fundamental things in the universe. In fact, without sound or waves, you would not be hearing this. In fact, without waves, you'd be like, and you'd only see this. Just imagine it's black. I do not know why it's red and now yellow and now back to orange. Just imagine that was black. And that's basically what waves and light and refractions technically do. Now let's start off with waves. Waves are basically what it is. You probably know what a wave is, right? It looks like this, and they can be like shorter distances between each other, like these amplitudes next to each other, or they can be like really long amplitudes next to each other. In fact, the shortest wavelength on the electromagnetic spectrum that we know is basically called the gamma rays. Also, we're not at the electromagnetic spectrum yet, so let's not even go there. Let's start off with light. Now, light is a weird thing. Most of the time, it's a wave. Sometimes it's a particle. How can that be? Well, photons create light. And that photon can literally do anything in it. But it also acts like a wave because different wave frequencies control what type of light it is. Personally, I like to imagine it like this, where it's a wave with a particle attached to it. Like a particle that's moving in the direction of wave and is leaving a trail that looks like a wave. And how fast it's vibrating or moving up and down makes it what type of light it is. And that's basically how I think of the whole shebang thing about, is it a particle or a wave? I think it's both. I believe it's both. However, lots of people are like, it can only be one! Things can only be one. Have you ever heard of quantum physics? No, and I'm not interested. So shut up and go away. What is quantum physics? Oh, you do want to know. No, I don't. Tell me, though. Yeah, gotcha. And yeah, pretty much that's what light is. And there are different ways you can actually use light. Light can be used as a reflection. I mean, technically, and in fact, this magnifying glass itself is a little reflective, too. Now, you might see my hat mostly, but if you look a little closer, then you'll see the whole camera screen a bit. And that's you. Well, at least technically that's me. And with that, you can literally create anything. In fact, that's what mirrors work. Reflection is basically just light bouncing literally back at the thing. Like if you tilt it at this angle, it will just bounce back towards you at the angle that was hit. And light that came from the angle. Now, lots of people used to say that light came from your eyes. Nowadays, we know that light comes from somewhere else. Light comes from somewhere else and goes into our eyes. And that's what makes this whole thing great. Yeah, that's a really big bright light, isn't it? And sometimes light can be altered so that we can literally use magnifying glasses to look at stuff closely and make these things bigger so that we have a bigger bunch of light. Now, here's how it works. This magnifying glass itself is special. This side curves outwards, curves inwards, and this side curves outwards. Now, this is called concave and convex. Convex lenses make things look smaller. Concave lenses make things look big. Now, both of them make it look bigger. Also, technically, if you look at it closer, one of them, well, yeah, technically this is both concave. But imagine this. Flip this around, and so that a convex lens will just make things look smaller. And if you don't do this right, it will just look upside down. And yes, you heard me right, it will look upside down. Now back to the video. We can also use curved mirrors themselves to do this. Now curved mirrors are useful for a bunch of things. One, it can reflect light. Two, it basically connects light, condenses light into one little spot in the middle of the curved mirror so that it sends everything outwards. And then we're gonna have to start talking about colors. Now, you might think there are a whole different colors. White itself is a different color. Yes, but white light is made up of different colors themselves. Now, if you use a prism, you can even use a water glass if you want to. And then you can split the white light into different pieces of of color. Now, if you look closely, you can see rainbows, right? Yeah, you can see blue, red, green, orange, yellow. You can see all those colors. You even see violet in places that you did not think it would exist. And so would this prism do it. This prism will do the trick too. If only I can get the light in. Ah, there we go. There we go. And this is basically how it works. Now, curved mirrors themselves work in the same way, except curved mirrors make things look curved. And this is also how fun houses of mirrors seems to work out. And colors are all from white light. Now, technically, you can create every color with just white light. The three primary colors of white light are... Now, this is actually a trick question. Lots of people, when they go to art classes, they're called the primary colors. Like the primary colors are red, blue, and yellow. However, the primary colors of light, it's red, blue, and green. And yeah, it's a trick question, to be honest, because you can use those three so that you can create different colors themselves. Now, each of them creates like magenta, indigo, and loads of other colors themselves. And it's even yellow itself. While red, blue, and yellow on paper and color and paint, it just makes it look good, and it creates all the rainbows, all the rainbow colors that we know. Light is way more complex than just like rainbows. In fact, if you like make a color wheel, you spin it really, really fast, you'll think that it's like white light, unless you're recording all that in slow motion, which is kind of a bummer. And then we have electromagnetic waves. Now, electromagnetic waves are a bunch of waves. Now, it goes out like this. Now, I memorized this already. The longest wavelength, the electromagnetic spectrum, is the microwave, and it's used for Wi-Fi, for radios, and for my mom to buy stuff on Taobao or somewhere else. Yes, and that is true. Or Amazon, but I'm in China. And the second shortest wavelength is the infrared rays, and those are the rays that you use to see heat. They're emitted by heat in your cells. Then we have UV light, which is not UV light, visible light, which is the light that we use to see, and it's kind of nice. It's why filters work. And then we have UV light, which is the shortest, which is just a little bit longer than visible light. And it is harmful. It's just, from now on, the ways I'm going to tell you from now on are going to be harmful. These don't do much damage. In fact, if you have darker skin, you basically have more protection from UV light. And then you can also use sunscreen if you don't want darker skin. I've learned it the hard way, and I really hate sunscreen, to be honest. Then we have X-rays, which are useful for seeing things, but they are harmful if they're exposed to for a very long time, and they can't penetrate metal and bones and teeth. And then we have the shortest wavelength, and that is gamma rays. The most dangerous rays of all. In fact, this is a type of radiation. And that's how the electromagnetic waves work. And without microwaves, phones wouldn't work. My Apple Watch and my iPhone wouldn't work. And I wouldn't even be able to go on blocks.io. And it's one of my most favorite games ever. You can find me as SeanPlays9474 on Lobby 100 in survival mode. Yes, survival mode. And now, finally, we're going to talk about sound. Sound is also a wave, except it's more of like dilations or ripples. Like if I say, stuff will basically pick up, and then it will just travel through air. In fact, sound waves travel through air, and air is the slowest way you can sense something. In space, you cannot hear anything, to be honest. And so what you do is that the fastest thing that can let sound travel is, well, apparently solids. Solids let sound travel fastest because all the particles are close together. and those particles vibrate, and they hit other particles to make them vibrate easier because they're literally already packed together closer. And so it's almost instantaneous to our perception. Air is the slowest medium, and water is the second slowest medium. Also, some textbooks say water is the fastest place. Other textbooks say it's solids. It's actually solids. Okay? Water is a good place to send, but it makes things sound murky. In fact, I tried to sing a song underwater, and they're all like, what a dumb guy. And I never did it again. And that's about it. That's it for waves, light, and sound. Until next time, Shannon out. Peace. Peace, 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 peace. Filter in, filter out, filter in, filter out, filter in, filter out, in, 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 out. Switch. Bye. Boom. Boom.